So this video is going to explain the main code for synthetic aperture sonar processing, what the code does, and eventually how it should be outputted to be put into ArcGIS. Understand that there are key issues with this code right now that makes it not function correctly. As undergrads, we don't really understand a lot of the SAS algorithms and whatnot, and as a result, we can't really fix it ourselves. However, I'll give you the lowdown as far as what we know. So the main file that we're concerned with is SASMapper. It essentially takes in the audio files for each of the three receivers and then processes them and finally outputs uh, those waveforms and whatnot into a BTY formatted file that could be read by ArcGIS. Now, going through this SAS Mapper code, you'll see the first section is sound file processing. We changed this semester so that the script will actually take in the .wave files from each of the three receivers that we have and actually put them into variables in the MATLAB code. Next, the MATLAB code then formats those variables as needed, and then we get to the synthetic aperture sonar processing section of the code. Here, each of these three waveforms from the receivers are put into the SAS code. I'll explain further as to what the SAS code does later on in the video. However, for now, just know that it takes in this receiver data and outputs in cylindrical coordinates an array for the radii and the heights of this data. Now, a little further down, you'll see that this cylindrical data is then put into angle interferometry, where it returns this angles array. This angles array is the theta angles that coincide with the radii and heights to complete the full cylindrical data, so that later on in the map reconstruction, down in line 91, it'll take each of these radii, height, and angles and actually create a XYZ mesh grid array of the receiver data. Now, eventually, this data has to be output into a bathymetry file or a .bty file. However, since the code still isn't running yet, we don't have the code to actually output anything yet. Now, going through the actual SAS code, understand that I know very little as far as what this code is doing, just generally the idea of what it's doing. So I'll explain the large chunks and then the critical part of the code that we cannot create well enough to actually allow this to run. You'll see at line 10, input flag 1 is set. This is essentially the variable that's used to determine whether the code runs in simulation or actually takes in the audio files that we are trying to put through the code. You'll see that it is actually set to 0 here, so that this, in all of our testing, has only run as a simulation. That'll make more sense lower on in the code. Now, all of this is just variable creation, which doesn't matter way too much for our purposes here, or rather, we don't understand it, so I couldn't explain it anyways. However, as we get down to line 121, you'll see this is checking for that input flag variable. For the next 100 or so lines, this is all running a simulation, which creates variables that allow SAS to essentially fake a lot of this with these waveforms to be outputted back to SASMapper for SASMapper to actually function well. However, if you go down to 256, you'll notice that the actual input flag 1 code, which means actual audio file processing, is very small. This is a couple lines of code that Will Willis and I went through this semester to try to create the correct arrays and whatnot for the later code to actually run. However, with a lack of knowledge of SAS in general, we couldn't really do much with this. So this is the section of the code that really would need to be beefed up and actually created in a correct manner for any of this SAS code, even the SAS mapper, to actually take in audio files and output the correct data. To explain a little more of the rest of it, digital spotlighting and all of these sections in between essentially improves data quality, but again, not in the scope of what I know and understand. Um, you'll see that once we get to 448, the actual map construction or reconstruction is started, in which we have two different methods of doing as such. We employed the first method, 2D Fourier match filtering and interpolation, which I also don't know too much about. However, it creates eventually these two variables, BAT-PTSR and BAT-PTSH, the radius and height data for this map construction to be returned back to SAS map.